Welcome to Share Science. Magnets are among the most neat discoveries on our planet, enabling a number of amazing technologies like generators and medical scanners. But have you ever wondered how they work? And how powerful can they get? Powerful enough to distort the universe as we know it? Let's tune in and find out. Today we are going to learn about 3 key things to help answer those questions. First, we are going to explore the electromagnetic effect, which is where magnetism comes from. Next, we are going to look at magnetic poles, which is how we characterize the effects of magnetism that we can measure. And third, we are going inside materials to look at how magnetic areas called domains can organize to create magnetic fields so strong they can pull objects from meters away. So, when we call something a magnet, what do we mean? From the days of antiquity, people recognized some rocks they pulled out of the ground would stick together and interact. Known as lodestones, these materials often held almost mystical status in many cultures worldwide, and now we know how they work. All magnetism is caused by the electromagnetic effect, which holds that magnetic fields are caused by the movement of electrons and vice versa. So if all atoms have electrons, why isn't everything magnetic? For a magnetic field of any strength, the electronic orbitals have to be partially filled, like they are in iron, cobalt, and magnesium. In a partially filled electron orbital, the electronic movement isn't canceled out by other electrons and can be thought of as tiny little bar magnets with a north pole and south pole. By definition, there are always 2 poles, and the magnetic flux always moves from north to south. These magnets tend to point in random directions to minimize energy, but under a strong magnetic field, we can align these magnets in the same direction. In a real material, like this iron nail, the neighboring atoms group together into magnetic domains that change direction together. When we apply a magnetic field, we can point all these domains in the same direction and make the nail magnetic. So now that we know how magnetism works, what's it got to do with the space-time continuum, and could it rip a hole in the universe as we know it? Astronomers made headlines recently with the discovery of evidence of a massive black hole at the center of our galaxy. But scientists have also suggested that such black holes may be able to connect to create Einstein-Rosen bridges, commonly known as wormholes, which theoretically act as galactic shortcuts for anything that could traverse them. Which is tricky, as our current understanding is the immense gravity of black holes would rip anything that enters apart. That's where magnetism comes in. Researchers have recently theorized that one could stabilize a wormhole structure with a dual toroidal magnetic system. How strong of a magnet would be needed? Common medical scanners can reach up to a few Teslas of magnetic field, and the strongest magnetic field ever made on Earth was upwards of 45 Teslas, and no signs of wormholes yet. But as we turn our gaze to the skies, astronomers have discovered a unique form of neutron star known as a magnetar with huge magnetic fields, upwards of 1,000 billion Teslas. Could this celestial body be the key to unlocking wormholes and intergalactic space travel? Only time will tell. To summarize, we explored the electromagnetic effect and how the movement of electrons can create magnetic fields that seem like magic. We examined how magnetic fields always operate as dipoles, with a north and south end, which organize within materials to create local areas of aligned moments known as magnetic domains. From this introduction, we reviewed common magnetic fields that we see on Earth every day to what kind of magnetic field might be needed to rip a hole in space-time itself. We hope you liked today's video. Look out for our follow-up installment next week, where we cover some of the amazing technology that integrates magnetism in our everyday lives. If you like this video, hit subscribe below, and you can get new content every week in your feed automatically.